We are looking at studying converting quadratic equations. We're going to be converting quadratic equations from one form to the other. So over the past few days, we've been focusing on two forms of quadratic equations. So one form is called vertex form. And vertex form is y equals a x minus h squared plus k. Our second form is known as standard form. And standard form is y equals a x squared plus bx plus c. Each of these forms have some unique properties. Vertex form is good for finding your vertex because the vertex in vertex form is h comma k exactly as you see them in the form. In standard form, the vertex is negative b, so meaning whatever the sign is here, it's opposite, dividing that number by 2 times whatever a is. And then to find your k value, you have to plug negative b divided by 2a back into the expression and get a value. Once you have your vertex from either form, the rest of the information sort of falls into place. Your AOS is x equals h, So if there is no transformations, then it's h. Your range is y greater than or equal to k, or y less than or equal to k. If it is greater than, then your graph has a min. If it is less than, your graph has a max. And we know if our graph has a min or a max by looking at the a value. And the a value in both of these equations is the same. So if I have a positive a value, then I have a min and my range is greater than. If I have a negative a value, then I have a max and my graph is less than or equal to. The positive a value will be open up. A negative a value will be open down. And last but not least, the domain of a quadratic is always and forever all reals. So you can write it as negative infinity to infinity or all reals. So taking all of that information into account, what we're going to do is convert our equations. So on the front page, we want to convert from standard form to vertex form. So in order to do that, I need to find my h and my k. So the axis of symmetry is negative b divided by 2a, which is negative 3. That axis of symmetry represents my h value. To find the k value, we have to plug that value back in. So negative 3 squared plus 6 times negative 3 minus 7. So negative 3 squared is positive 9 minus 18 minus 7. So you get negative 9 minus 7, which is negative 16. So my vertex is negative 3, negative 16, which means in vertex form, it's y equals, a is 1, x minus a minus 3, squared minus 16. And again, if you want to change the double negatives to a positive, you can, but you can also leave them as is. Let's look at one more example. Number 2, mainly because number 2 is a little unique. This is my A, that's my C. My B term is 0. So that makes my axis of symmetry 0. Because what happens is this graph at x squared minus 64 is shifted 64 units down, but no units left or right. So if you plug 0 back in, 0 squared minus 64 is negative 64. So that makes my vertex 0, negative 64, which makes my vertex form x minus 0, which is just x squared minus 64. And what we notice is when we have a b value of 0, vertex form and standard form are identical. Vertex form and standard form are identical. The second concept that we're going to focus on is going from vertex to standard. And this one requires a little bit more work. So the axis of symmetry is pretty easy. Now this equation here, we need it to be set so that it's like y equals. So we're going to move over our 5. So it's x plus 5 squared minus 5 equals 0. So you just have to subtract over that 5. My axis of symmetry is the opposite of what's inside, so that's x equals negative 5. My vertex is the opposite of the inside, and then the number outside, so that's negative 5, negative 5. And then to get to standard form, you have to FOIL and combine like terms. So x plus 5 times x plus 5 becomes x squared plus 5x plus 5x plus 25 minus 5. Because you have to take the x plus 5 and FOIL it, and then tag along your minus 5. So I get x squared plus 10x plus 20. Let's do one more of those, but let's look at 16 because 16 looks a little bit different than 13. So 16 is already in standard form where we're set equal to y. So once again, my AOS is the opposite of the inside. My vertex is the opposite of the inside, and then the k value, which is negative 2. And then I'm going to FOIL. Combining like terms, I get x squared plus 2x minus 1, and that's my standard form. It does get a little trickier as we move down to number 19, only because now I have an a value. So we have to FOIL first and then distribute a. So my AOS is 4. My vertex is 4, negative 5. And now I have to take 2, x minus 4, minus 5. And you have a couple choices. You can distribute the 2 into x minus 4. You can FOIL your x minus 4s and then distribute the 2 into every part. It's really kind of your choice. I think the best bet is to distribute the 2 and you only distribute it into one term. So it becomes 2x minus 8, x minus 4 minus 5. Now you FOIL. Now you combine like terms. And you have your standard form. All right, ladies and gentlemen, you're finishing the rest of that handout. So it's 1 to 24, and I already did 5 of the questions for you. Have a great day.